Hey everybody, my name is Safwan.
My name is Asad Siddiqui.
Alright, so today we're going to talk about exactly how combustion works. So you turn on your car in the morning, leaving for school, and you're trying to wonder, one day exactly how your car gets up and running and how it starts. So what makes your car run is actually combustion, and combustion is it deals with an energy source and comes out in the form of carbon dioxide and water. So that's why on a winter day, there's steam coming out of your exhaust pipe, and also that's when the water condenses, and you also see water dripping out because that's the result of combustion. So combustion has to do with your fuel compressing in the cylinder with air. So exactly how this happens is you're driving down the road, you step on the gas, fuel gets injected straight into the cylinder. Now, you guys probably don't know what a cylinder is, and a cylinder is in your car, and it depends what type of engine you have. So if you have an inline 4, you have 4 of these. If you have a Lamborghini and you're rich, you have a V12, so you have 12 of these. So what this cylinder acts as is a combustion chamber. So you have air flowing in from the air intake of the car, and when you step on the gas, fuel gets injected into it. And what's happening is you have the mixture of gas and air and the piston moving with the crankshaft. So that's going to create kind of like a compression, and that turns into the form of exhaust, which is CO2 and H2O, so carbon dioxide and water. So that is what ruins the environment, that CO2 factor of combustion. So.
Alright, so another thing I want to add on is just that the more of these cylinders you have, the faster you go. So moving forth is where do we get, the hydrocarbons from in this whole entire, combustion reaction. So if you see down here, we have hydrocarbons, we have oxygen, which produces, carbon dioxide and water. So the hydrocarbons actually come from petroleum, which is an oil that's dug up in, out in the west, at those, in those oil refineries, obviously. So basically, when you go to a gas station, when you pull over at a gas station, you fill up your car with fuel, right? That's exactly what you're putting in there. You're putting in hydrocarbons, or in this case, octane. Now then, obviously the O2 is air or oxygen. So, that's where the air intake comes in handy, and it'll actually, suck in air so that way it's able to actually complete the combustion reaction. Now, as for the products, right, it produces carbon dioxide, which obviously will ruin our environment. But the issue is just that, you see the carbon dioxide in the form of gas coming out, or smoke coming out of the back, out of the exhaust side. Now, the water, right? The water is probably one of the most important factors because of the fact that, it actually helps cool down the engine. You see, the thing is just that you don't want an overheating engine, because if the engine starts overheating, then a lot of bad things are happening. So obviously, if your engine's not cooling down, then something has gone wrong in your cylinders or in your spark plug. So moving forward, these are the potential models. So as you can see here, there's a lot of double bonds happening between the carbons, which actually allows it to continue the chain of reactions. Now you have a huge group of O2s. In fact, you have 25 O2s over here, because that's exactly how much is needed for at least one cylinder to keep doing its job.
And we're talking about octane as our fuel, right? So that's most cars, octane's a fuel. So we have octane mixed with all of these oxygens, because obviously your engine sucks in the air in your air intake. And then coming over here, the reaction part of it, when your piston and crankshaft move, you're starting to get these CO2 molecules, which are the ones that actually ruin the environment. And that's what happens in your exhaust. And then you're having all these H2Os coming when it condenses, when there's steam, when there's water dripping out of your exhaust. So that's the product of combustion. So let's move over here and just go over it one more time. So we have air here. Okay, this is your O2. Your O2 is coming in here into your combustion chamber in your cylinder. So here's the piston. Fuel is being injected as the air comes through. Gas and air combine as the piston moves to compress it, and it comes out in the form of exhaust because of combustion. Now, combustion is actually fire. So it is an exothermic reaction. So that means that it doesn't need heat internally. It actually creates heat because combustion is fire. So fire is actually made from combustion, and this is kind of a similar concept here that we have. So yeah, and also you might ask how conservation of matter comes into this. And that's because you have a very high kinetic energy in the octane that we have here, and also in air. But then you notice that water comes out of it, and water is not doesn't have the highest kinetic energy. It actually has a lot of potential energy. So you take that and take the difference of it, the conservation of matter comes in and actually conserves the matter, and nothing really goes to waste. So that principle is still applied here. It might be a little hard to grasp on, But combustion is very much, conserves matter in that sense. So yeah, so that's how your car works, and that's how your engine works. That's pretty much it. You have anything else to add?
Right, and as for the finishing touches, obviously we have 2 moles of octane, 25 moles of O2 or oxygen, 16 moles of carbon dioxide, and 18 moles of water. That's the actual equation itself.
Yeah, that's the combustion equation for your car. So yeah, combustion also works through airplanes, trains, pretty much anything with an engine, anything to do with heat. It's just that we're doing combustion for a vehicle. So this is pretty much the equation for your car. So when you start your car up in the morning, you might want to think about how combustion works and how it's used in your daily life to transport you to places. So yeah, thank you.
Thank you.